So welcome to the EPOS data portal training arranged by University of Bergen together with EPOS Eric, with participation of GeoInquire and Skills for EUSC projects, who are contributing on different aspects of the open science and making data available and shared. The agenda for the training today is as follows. I will provide a short introduction of the EPOS ecosystem at the beginning. Then we'll go for a live demonstration of the EPOS data portal by following a scientific user story that will be given by a colleague of mine, by Harald. And then from 10:30 to 11, you will have time for your own hands-on training by following a scientific use case in a specific form. And also we will collect feedback from you about the training itself and the EPOS data portal. What is your experience? At the end, we will provide a short walkthrough through the individual task from the hands-on training, so you can kind of get confirmation whether or figure out why something didn't work as expected, or just confirmation it worked and that you did well. And then the last 50 minutes at the end, we will have time for discussion. It's generous time, so you can also use the Q&As during the presentation now. You can paste the colleagues of mine can try to answer those, or I can also assist you later. But we'll focus answering all the questions to the last part of the discussion. The presentation will start with introducing the open science. You are pretty much familiar with that, I believe, especially related to open access papers and journals for publishing the results. But it's not only about that. The open science is introducing a new way how to share the data and all the work actually the scientists are doing. So it focusing on open data, open source, open software, also open methodology. So describing whatever you are doing in an open way, so anyone can actually reuse that. Similarly, the open educational resources, so make the materials you are preparing also reusable by others. So open science represents a new approach to the scientific process based on a cooperative work and new ways of diffusing knowledge by using digital technologies and new collaborative tools. That's a statement from the European Commission document. And the primary goal is that to make whatever is generated by public funded sources to make available again for the public in a digital format with no or minimal restriction. So whatever you produce, thanks to public funding, it should be also made available. And that's what also EPOS is trying to do, making all the data which are already being shared, integrate and provide an easier access to those assets through a common platform. The open science brings its own benefits and barriers. So the benefits, you will always have the data much easier to access in a good time. So making actually the most of the data which are available. Verifiability, it means that all the data are already approved by someone or those who generated those data. Reproducibility, so you can reuse the data and reproduce the results which were achieved by other scientists. And of course, in that way, you will use efficiently the research resources, so you will not need to reinvent things, because if the data is already there, you can just reuse. And of course, if the methodologies are open as well, then you can just use it for your advantage, for your research. Of course, there are difficulties also how to get there, because it requires an additional work, let's say an overhead, which is coming on top of what you are normally doing. because you need to understand the different standards, different vocabularies. There's a lot of fragmentation which needs to be removed. It might require a lot of communication between you as a scientist and the IT experts to understand how actually to get the data integrated and follow the standards in the best possible way. Making it also creates an overhead to make the data open and fair. I will explain what the fair means in the next slide. And of course, there are also might be perceived issues on the intellectual property rights. Who is actually the owner? So that's also sorted usually by license. So everyone is assigning license to his own work, and then also, of course, having the digital identifier or DOI, so then anyone else can use and cite properly the work which has been published. Of course, the legal and ethical issues, how to use, by whom to use the work, those are also difficulties, but it's not possible, or it's not impossible to overcome those. As I mentioned, the FAIR principles, they are well known and discussed at many different levels, especially related to data management. The FAIR stands for findable, accessible, interoperable, reusable, and the last R, which is now in the parenthesis, is making that everything also for machine readable. So it means that not only humans can comply with these principles, but also machines. So it means you need to have correct metadata models which the machines can understand and interpret and connect to other assets in the best possible way. In practice, the open science, it means that it's a lot of communication, consultation, and co-creation, and that's what it's integral for EPOS. So we are not just creating catalogs, but we are adopting a service-driven approach to openly share the data and products, and it's especially driven as bottom-up through the communities. So we have 10 thematic communities within EPOS, and that we are actually building on top of those communities and their services. It requires collaboration among scientific staff, the IT and the governance components are key, how to actually glue everything together. And of course, engagement of the communities is the crucial thing, especially for harmonizing the data and processing them and making them standardized. So, of course, making with the only ultimate goal to make everything ready and usable by the scientists. So it's work done by scientists for scientists, and everything it's open publicly and free. So that's the advantage you can use of. EPOS, the European Plate Observing System, it's moving toward global science. So trying to merge everything into one place and make it available from one place. And the goal is to have the infrastructure long term. So building it, it's not just a project, it's an effort which started already back in, let's say, 90s, the idea how to make things happen. And it's evolving, and since 2016, we start developing the system, and also on the governance level, it's getting more and more coordinated. And now there is an EPOS ERIC, and ERIC stands for European Research Infrastructure Consortium, which has been established in 2018, as you see here on this side. Now it's a legal body residing in Rome and governing the further EPOS developments. In 2023, the EPOS data portal as a main product was launched into operational during the EGU in Vienna. And since then, we're trying to convince scientists that to use it and training them and explaining how the EPOS works, how the portal works, and how also the data flow works, and how to get the data into the system, also from new communities and new countries. As I said, EPOS ERIC has been established in 2018 as a legal entity, and it's recognized in all EU member states. And the principal task of an ERIC is to establish and operate a research infrastructure. In the map, you see in the dark green the members of EPOS ERIC. The light green are the observers, currently Germany, and plus the red countries which are included in the EPOS integration plan, but not yet integrated fully. I have some additional numbers here of what currently we do have in place. We have about 87 data and service providers connected in the system, but there are actually even more data providers behind. Let's say these are those we can easily count. We provide access to more than 800 terabytes of data, which are distributed around Europe. So our system is not downloading anything to a central local place, but we are just making things connected at the European landscape, at least for now. Currently, we have 264 data services, which you will then explore partially yourself or anytime later using the EPOS data portal. So far, we had more than 16,000 unique visitors in the EPOS data portal since the operational launch in April last year. Just briefly mention the EPOS research infrastructure and the architecture behind how it actually works. Just give me the laser pointer. So you see on the left-hand side are the thematic core service, which are actually building the whole EPOS community. So those are the data providers and service providers which are connecting to the central system and providing the data products, software and services through an interoperability layer. Technically, it works that currently EPOS is supporting the data provision through services. So those services needs to be mapped into metadata structure, which is called EPOS DCAT AP model. And then we ingest the information about the services into our central catalog. And from then on, you can search through the catalog and then connect to individual services back at the thematic core services level. So that's what we call the central system, which provides the catalog of the services, but also having other components for connecting things together. Also the graphical user interface of the EPOS data portal, the APIs, which are driving the whole system in the background. On the right-hand side, you see distributed core services, as we call them also ICSD. Those are potential new components which will connect to the central system. It can be HPC, it means high performing computations or high throughput computations, additional visualizations or extra storage or other IT resources. So those are planned and now being developed as pilots. I will show you a few slides about that, the pilot implementations we have now running. But currently what you can get is basically the access to the thematic core services. So you can find the data, download it, or even pre-visualize on the EPOS data portal in a simple way. The main users, considered users of the EPOS system, are scientists, but also governments, private sector, and society. Anyone basically who is interested on getting high quality data, which are approved and served through the communities. Here I have introduction of the 10 current communities we are working with and from which we are integrating data into EPOS. So the first is seismology, the waveform services, seismological products, earthquake hazard and risk products, for example, maps. And the next community is near-fall observatories, which are providing access to seismological, geochemical, and geophysical data around the large faults, and known faults or seismogenic faults in Europe. Third community is providing access to GNSS data and products, again at the European coverage. Volcano observations. This is a multidisciplinary observations around the volcanoes, Iceland, Italy, also France, and Greece. So we have several areas where we have observations of volcanoes. Then satellite data. Currently, we have mostly INSAR data and their products, which you can find. And next community is geomagnetic observations. Those are mostly global observations of the geomagnetic field, but also individual survey data based on magnetotelluric observations. Community anthropogenic hazards is observing or collecting observations around mines or exploited areas, like wherever humans are extracting the energy or resources from the earth, and monitoring those areas. So be around the old mines or exploitation area, for example, of geothermal energy. The next community is geological information modeling, providing access to boreholes around Europe, the geological maps, also 3D 4D models and mineral resources. Multiscale laboratories are dealing with observation in labs. Those could be analog modeling of geological processes, paramagnetic and magnetic data, and rock and melt physical properties, basically measuring on samples. The last but not least is a TCS tsunami community, which is the newest one in the EPOS community, and providing tsunami data, observations, and also hazard and risk products. The technical architecture, how everything works. So today you will see the EPOS data portal, which is the GUI, the graphical user interface on top of the whole system. But that actually what you will see is just a tip of an iceberg, because the actual work and data lies beneath. So once you go to the portal, you connect to our central catalog, which is actually the ICSC, the centralized services. And from there, we are redirecting you to individual services, which are at the bottom, to individual communities. So if you select a service, for example, you want to get a geological map, we redirect you to a geological information modeling community server and getting the data right from there on the fly as you requested. So it has an advantage and also disadvantage. The advantage is that you are getting the data up to date at any given time, because you are always asking to the source of the data. The disadvantage is that since it's a federated system, it means that everything needs to be connected at any given time, or at least when you are trying to access the data. So if something goes down, we might have trouble to get the data for you. But we have also a monitoring system in place, which is observing frequently every 15 minutes, querying the individual services. So we have good understanding what is working and what not, and if not, there are notifications and so on. So the whole system is being monitored, and we know what is happening at any given time. The EPOS data portal is built in having the FAIR principles in mind. So we're trying to apply the FAIR principles everywhere where possible and integrate the practices. And that's possible thanks to co-development approach and harmonization actions across the communities and developers and data providers. So this is a screenshot of the EPOS data portal. with some services in my favorites. And this is the current status. You will be able to come to that in a minute, but please don't go there yet, because we want to give the live demonstration, and afterwards you will have time to do your own hands-on practice of the portal itself. Just 2 more slides about the further developments we are working on. So now currently the EPOS data portal, go back, provides data discovery, pre-visualization and download. But we think further than that. We want to provide the scientists truly processing environment, so they can not only find the data but also do the processing online from any place. So we are integrating now Jupyter Lab environment, so you can connect it, or we will connect it to the main portal. So once you find the data, you can deploy them on a specific virtual environment and then do process the data using, for example, Jupyter notebooks, and make either processing or visualization there. In addition, we are connecting an additional Enlightened Web, which is a visualization tool allowing different views and viewing the data in linked views. So here you see 4 different maps of 4 different assets, but you can also show the plot, let's say the data in 2 different plots of the same data, just different views. And those are kept linked. So if you, as you see in this right-hand plot, the black rectangle, the data selection out of the big cloud of data, it's also then linked and highlighting the points in the left-hand view. So just to explain what we are working on, we have the pilot implementation in place, and we expect that to have it in production by June or September this year. So that's all from my side. I will now give floor to Harald to provide the live demonstration of the EPOS data portal.
Hi, I'm Harald. Thank you for the introduction, Jan. I will introduce a brief demonstration now for the EPOS data portal. It's great to see many people here. And can you see my screen now? Can you confirm on that?
Yes, I can.
Very good. So the first thing you're prompted with is this pop-up. And here, if you want, you can have email updates for future updates on the EPOS data portal. You can also start a guided tour, which goes through the elements I'm going through now. So let's see, I can press now, continue to the portal, and it's saved in a cache. So on the left-hand side now, we have a pane called data. You see a number here, it's 264. That's the amount of services available. So if you press this one, you can see the symbols here. Those are the thematic core services. These are the communities that provide data, which are visible now in this GUI. So then you have the data pane here, and you have the free text search here. And you can refine the search here with spatial or by 2 different methods, like coordinates or by country. And then you have a temporal range here you can set for your data. You can set the service providers, and you can also set data visualization, the 3 different ways of displaying the results. So now we are going through the other ones. You also have a location search here for specific places. You can zoom in or out here. And you have a layer and legend tool here. You can control all your selected services and the background layer. Then you have table view for the services that are displayed in that. And you have graph view for certain elements as well. Also in the menu, we have video guides where you have these as what Jan just showed is mainly showed here in the intro. But if you want to go further, you can go on data search or configuration and visualization of services to get an introduction there as well. Then we have the guided tour, which are basically going through what I'm going through now, step by step, and showing how to configure things and how to modify and what the different things represent. how to make bounding boxes and configure things further. Okay, so now I will do a text search on, let's say, geological map. Sorry. And then I will select the service here. You can put it to favorites directly, or you can click on it here. If you put it on favorites, then you can access your favorite here as a workspace. Now you can see the different layers are loading here for Europe. If I'm searching here for a place, it will zoom in and suggest a place for you. And then if we zoom out a little bit, it will reinitiate. Takes a second. In the background here, you can see Vesuvius, and then you can see Campifigure here. The two different volcanoes are the largest, most prominent volcanoes in the Naples region. So now that it's loading here, you can press on the map. So I could try to refine it. You can also refine the search, then only the area you have chosen will load. There we go. So this layer here is rhyolite, which is a extrusive volcanic rock, and its origin or its age is from Pleistocene. And let's see for Vesuvio. So also rhyolite here from the same age. And you can also modify the layer to be more transparent if you wish to display it like that. And I can customize here, and then you can see through like so. And let's say if we want more layers on, we can do that. Now I remove the free text search, and you can see all of these panes are now accessible. So I want to have a look at INSAR data. So line of sight displacement time series is one of them. And you can specify a data provider and the amount of tiles. And then we can see a different picture here. So these colors you will investigate later, but they represent the vertical displacement. And if you see here on the pop-up, it says the name, or in the name, it says the period. So there's a 6-year period. This is on average calculated from. So contrary to mainly, I don't know, a belief is that Vesuvio is subsiding now, and Campifigure is quite active, at least in this period of time. And the last eruption here was in 1945, and this one is actually like 500 years ago, but it is much more active now. So if we want to further investigate this, we can search for example, modern earthquakes, and then we have to go to seismology. And if I choose this one here, it's default set to 5. So 5 is quite strong for an earthquake in a volcanic area. So if I set this to 3, you'll see a pattern here. So it might be difficult to see here. Then you can modify the display of the service here. So you can have the marker icon as non-transparent, and you can choose the opacity, and you can set the color also so it's contrasting to the other ones. So recall that these earthquakes are from the last 25 or 6 years. Then you can further modify those. Let's say if I want to have the entirety of last year, I can do so here. And then the minimum magnitude here is set to 3 to have the strongest earthquakes visible. So if you recall or are familiar with the area, you can see that all magnitude 3 or higher earthquakes are in this period in this area. You can also see this in table view. So by default, it's set to 10, but you can set it to more. Right now, coincidentally, the amount of earthquakes over 3 are 10. You can also modify, or you can download these in CSV format if you prefer that here. And you can also download the data in this period as different formats here. And then it will prompt you with the XML, the Quake ML or XML, then JSON and the text as well. So then you have multiple format depending on the provider where you can download it. Okay, so if we go through, if I modify this one, we can also have a look at GNSS stations. So then I go first to GNSS stations with products, and then you can see the pop-ups here. If it's too difficult or too much things going on, you can always turn on or off these layers. You can also change the background layer. Sometimes I prefer to have dark gray, so you have the best color representation or contrast. Okay, so within this one, you can see a 4-letter code. This one is important. So if I want to find the GNSS station closest to Conflagray, it's this one or this. Then I can copy this, and then I'll go to some of them that has graph view. Like, for example, this one, daily position time series from INGV. The trick here is you have to go on the advanced search filter, and then you can paste your 4-letter code. And by doing so, you have this set to graph view. And within here, you can have the east, north, or up component. You can also specify this as X, Y, Z if you prefer that. Instead, here you can save this plot as a PNG, like a snapshot. And you can zoom and hover around here if you wish that as well. So I can zoom into a specific period, and you can go through here. And if you want to reset this, you press the home. So then I briefly introduce the graphical user interface. Like you would go through different cases now. So then it'd be useful for you to know how to reset things between the different cases. So you can press the clear all favorites, and then you can remove the spatial. And if you have something here, you can also remove that as well. So now I'll briefly go through some tsunami services and some faults as well. So like I showed for now, I used the free text search, but you can also browse through the catalog here from different community. And if I choose 3 of these services, one is submarine landslides for the Mediterranean Ocean and scars here. And then for this case, paleo tsunamis. So given a few seconds, here we go. So the scars here are the areas that has been mapped where these landslides used to be before an earthquake or an event that triggered the slide of them. So if we go to Sicily, close to Etna, you can see if I press this point marker, you will get some information from a research paper giving 3 strong recorded events in old times, since this is paleo tsunamis. And then, for example, if I go to this one, it will give the same age as one of the tsunamis. So at least when you have for example, the scar here, and you have the submarine landslide, and you have the paleo tsunami, at least the interpretation is up to you. But at least then you have some indication of what process has been going on. So if I briefly go to Stromboli, which is quite frequently active, there are 3 tsunamis events. But on this side, it seems like the scars and the submarine landslides is on the other side. So these probably are from another event. Yes. And then if I zoom out a little bit more, you can see some submarine landslides that are the size of both Sicily and Corsica together. So quite massive forces making these. Okay, so if I want to search for faults, let's see how they superpose and correspond. Okay, let's see under seismology. So there are a number of these. Some of them are called database of seismogenic faults. And if I press this one, it's a collection of the crustal and subduction faults. If the colors are too similar to the other things, you can always go into the layer and legend tool and you can modify those. So here you can see what the different lines represent and the depth of the subduction zones. And you can at least modify the opacity of this one. And if you want to change another color for these ones, you can do so as well. So those pop a little bit more in contrast. But yeah, here you can see the distribution of the faults, and you can see the tsunami events, and you can also have old earthquakes or modern earthquakes, and see if you can find some relation between these at least. So yeah, that's my basic introduction to the EPOS data portal.
Thank you, Harald, for giving the live demonstration of the portal. Thank you and goodbye.